Good evening, everybody. I hope the recording has begun. Welcome to the first round of the debating competition, and the top motion for the debate is: this house believes that interstellar travel will become a reality. The government is the proposition is cryptic dark matter, and the opposition is blazing blazars. I would now request the first speaker from the proposition to present their arguments. Timer, please start the timer as they
Yeah,
begin.
I'll give you a short countdown before I'm about to begin. Am I clearly audible? If you could just give me a confirmation.
Yes, you are.
All right, fair enough. Do I need to set a timer for myself, or
You can just
that
watch the
would?
screen.
Cool, fair enough. Yep, yep. I'll begin in 3, 2, 1. Good evening, everyone. I'm Harshit Singh, and I'm the Prime Minister for this debate. We, the side government, have a very clear idea of what interstellar travel is and how we look at it. Interstellar space travel is manned or unmanned travel between the stars. Though theoretical, the idea refers to interstellar probes or crewed spacecraft moving between stars or planetary systems in a galaxy. To make it very clear, we don't want the opposition ranting and going on about questioning how this will happen. Because for sure, though theoretical, the interstellar travel idea is possible and will be seen in the coming few decades as research in this direction is already underway. What we want from the opposition is to tell us what law or phenomena outright forbids it. Is there any? I guess we won't get any answers to that. As the Prime Minister, I'll be presenting the definition and the keywords of this agenda, give you an introduction of the topic we are going to debate, and provide you with a few arguments that will bolden our stance. The Deputy Prime Minister will rebut the points stated by the Leader of Opposition and add upon our stance by providing more arguments that favor us. At the end, the government whip will rebut all the statements made by the side opposition and tell you why we feel we take this debate over them. The agenda states, will interstellar travel become a reality? Now we'll tell you why we strongly believe that interstellar travel will become a reality. We'll now lay down arguments that support our stance in two manners. First generic and then specific. The very first argument. The agenda doesn't talk about a specific time frame in which the capability of achieving interstellar travel will happen. Therefore, we don't have a time limit set to our head, a bomb which will burst after the end of this debate or in the next 100 years. Hence, it is out of the agenda for us to debate the time when this will be possible. And hence, questioning the reality or possibility of interstellar travel is not something we should be doing. It took humanity several thousand years to think, and more than 100 years after the Industrial Revolution began to go to the moon. A few decades ago, it seemed impossible, and several reasons were given to prove that reusable rockets would not be a real thing. But here we are, contradicting people who stepped on the moon and armchair experts who said that this wouldn't be a reality. But alas, it is. Now, the biggest hurdle to mounting an interstellar mission may be humanity's short attention span. And we definitely don't excel at taking or tolerating the long view. We are nowhere limited by research. And I ask you again, is there any research that forbids interstellar travel from becoming a reality? No. The second argument, we'll come into the specifics with this. All right. With the currently available technological resources, a very practical and optimistic effort is the Starshot Breakthrough Initiative. And to summarize its basic idea and functioning, this involves a ground-based light beamer pushing ultralight nanocrafts, which are miniature space probes attached to light sails, to speeds of up to 100 million miles an hour. In case you were wondering about the impacts with tiny dust grains in the interstellar space, such events shouldn't be a big deal for the Starshot probes, even at 20% the speed of light. With the current rate of research and all the resources we have at present, the Starshot Breakthrough Initiative should be completed within the next 3 decades. Breakthrough Starshot aims to demonstrate proof of concept for ultra-fast, light-driven nanocrafts and lay the foundations for a launch to Alpha Centauri within the next generation. Along the way, the project could generate important supplementary benefits to astronomy, including
POI.
solar system. All right, go ahead.
Okay, so you talked about the probes that are the Starshot probes. So these probes are in fact heading in an escape trajectory. So who's to say they actually leave the heliopause and they actually reach another star? Because what we are talking about here is interstellar travel. So
Right.
how do you
Yeah.
explain that?
I get your statement. The point is that the interstellar travel that we're talking about and the Starshot Breakthrough Initiative, this isn't just one nanocraft. These are several thousand nanocrafts which would be powered by the sails they have, and the light beam which would be directed from Earth itself. So in case one or two of them fail, there is a very high probability that the others will reach the destination they are destined to reach. All right, I'll go ahead with my arguments. Yeah. Therefore, this must not be assumed as an initiative that will abandon all the ongoing projects, but rather an initiative which will be auxiliary to the ongoing projects, providing assistance and well-rounded research for the future. Therefore, this is just the beginning. The idea is realistic and possible, therefore taking us a step closer to achieving interstellar travel. With proper funding, societal support, and research, this initiative will be a reality in less than 30 years. We don't say that this would be a walk in the park, but at the same time, we also say that no scientific breakthrough has ever been a walk in the park. And to reiterate on what they are, they're going to the moon or building the first aircraft, which at one point of time seemed unrealistic. And to conclude, I'd like to give you a short statement. We have already achieved the capability of slow interstellar travel, and therefore the possibility of achieving fast interstellar travel shouldn't be ruled out. Even though we are functioning in the paradigm of, I'll just conclude. Even though we are functioning in the paradigm of an agenda which doesn't specify time, and to reiterate again and again, because there is no research which forbids or denies the possibility of interstellar travel. Just because we entirely focus on the short-term future, we completely ignore the long-term benefits for the entire civilization. And therefore, I'd like to conclude my speech by saying that we aren't short of time of research. We are short of patience and the ability to accept the fact that interstellar travel will be a reality. Therefore, I'd like to end my speech here. Proud to propose. Thank you so much.
Thank you, first speaker proposition, for your arguments. Now I request the first speaker from the opposition to present their arguments.
Hi, yes, am I audible?
Yes, you are.
Hi, Mehak. Would you like to, would you like me to tell you at the end of 5 minutes or like in between somewhere?
Yes, please.
Like, what time do you want me to tell you?
15 seconds before the 5 minutes.
Okay.
Yeah. Okay, so I'll begin and I'll just count to 3 and then I'll begin. All right, 1, 2, 3. A very warm good morning to one and all present here. Today, we, the members of Blazars, will be orating our views on the topic, is interstellar travel really possible? And we will be speaking against the motion. Is interstellar travel really possible? Of course, there is nothing physically barring or preventing travel to another star as the answer to the Prime Minister's question. However, when people ask, is interstellar travel possible, that's usually not what they have in mind. There's a big difference between what's possible and plausible and feasible and achievable. Thus, when people ask, is interstellar travel really possible, what they want to know is if the travel is realistically feasible, which, my dear friends, I can assure you is not the case in our current generation. In order to demonstrate this, let's have a look at one of the fastest objects that humans have ever created, the Voyager 1, that travels with the speed of 15 kilometers per second. Now, that does seem pretty fast, but if you want to go to Mars with that speed, it would take months to get there. If you want to go to Pluto, then it would take us about 10 years. Since we are talking about interstellar travel, let's have a look at our nearest star system, the Alpha Centauri, which is about 4 light years or 38 million kilometers away. And to get there at the speed of 15 kilometers per second, it would take us about 30,000 years. So unless we can raise hundreds of generations of people in space, it's pretty impossible. So the calculation and logistic technicalities required for human exploration to be possible through interstellar travel are mind-bogglingly off the charts. As for claims about the interstellar travel by NASA, projects such as the Voyager or the Starshot that my opponent presented, outside the heliopause that are traveling in an escape trajectory. These probes are merely chunks of metals that are slowly losing energy and power and eventually will shut down and just keep floating to the vastness of space, cold and alone. Thus, for a non-feasible certain definition of interstellar travel, we have in fact achieved it through these cold alone chunks of metal, which I'm assuming was not the ideal situation that we were hoping for when we came up with the idea of interstellar travel. Moreover, these probes were not pointed in the direction of the stars because their mission was to simply profile the planets and were set to a trajectory, and so now they would just be out there going in any random direction. Suppose these probes were in fact pointed in a direction, for example, our nearest star, the Proxima Centauri, then for the probe to reach there would take about 80,000 years. So yes, interstellar travel is possible if you're willing to send inert constant metal flying through the void for tens of thousands of years. So,
Priya,
mission accomplished. Yes.
so our first speaker did say that the final speed of the probes would be close to light speed. So, how can you say that it would take 80,000 years to get to Alpha Centauri?
Okay, even in that case, there would be other factors that come into play, like the interstellar environment, such as the dust particles, the meteoroids, and yeah, so that's basically even other factors come into play in that case. So continuing, in today's generation and for the coming generation, I believe that interstellar travel would be a work of fiction. Over the course of years, there has been a massive development about the antimatter space propulsion that was earlier seen in the famous Star Trek series and now become a reality, close to becoming a reality. But however, the problem with working with antimatter is that one has to keep it from touching matter, which surprisingly is hard to do so. But apart from this, the other issue that arises with rockets and probes that require antimatter as a fuel is the production and storage of antimatter, which they were able to do in Star Trek, which again is a work of fiction. Closest that we have come to producing antimatter is less than a gram, and closest we have come to storing it would be for less than a day. But even if humanity were to develop a particle collider that would be able to generate large amounts of antimatter, the amount of money that it would require, along with the time and resources, would not fall under the lines of being feasible for our generation at least. Another factor that comes into play, like I stated before, is the interstellar medium. A major issue with traveling at extremely high speeds is that interstellar dust may cause considerable damage to the craft due to high relative speed and large kinetic energy involved. Another factor is the hazards. The crew of an interstellar ship would face several significant hazards, including physiological effects, long-term isolation, the effect of exposure to ionizing radiation, and the physiological
Minutes
effect
45
of
seconds.
okay. There also is a risk of impact by micrometeoroids and other space debris. So yeah, basically with the current technology, I believe interstellar travel is nothing short of a far-fetched dream for humanity right now. Thank you. Uh,
Thank you, first speaker of opposition, for your arguments. We'll now proceed to the second speaker from the proposition.
Am I audible? And my network was a little unstable in between, so just let me know.
Yes, you are audible. We'll let you know.
All right. Just a countdown. 3, 2, 1. Good evening, everyone. I am Oliver Pereira, and I am the second speaker for the government today. Just to point out some of the points which the opposition speaker said. She said that it is not realistically possible to have interstellar travel in our generation. But we would like to bring back the point that the debate just asks whether interstellar travel would be possible, and it does not set a time limit to it. So it could in fact be possible, but maybe whether it's 50 years or 100 years, but it could eventually be possible is what we are going with. To continue with our first speaker's point, the nanoships in the Breakthrough Initiative receive power from the lasers. So basically, there's no wastage of space for fuel as would be in a conventional rocket. There are no external moving parts, so there's less chance of mechanical breakdown. And basically now with the kind of technology that we have, an entire science lab could be packed onto the chip itself. The cameras, sensors, radio transmitters, whatever would be needed. The journey is hazardous, yes, we agree. And so thousands of these ships would be sent, and just a few of them would succeed. So there's no worries about the deceleration of the ship itself. Once it reaches its top speed of 20% C, the ship would just the ship would get a few hours to complete its mission once it reaches the Alpha Centauri system, during which time it can take the photos and the data and send it back to Earth. For a practice run on these ships, we could send them to closer destinations, to the moon, to the planets within the solar system, and this would enable us to do our usual planetary missions in a few days. The future the future plans for this could be that we could have lasers. We could have these lasers in space itself. So, for example, we could have it on a lunar base, so that we do not lose out on the laser's energy due to it passing through the atmosphere. And we could have more relay stations with lasers and with these robots at the Lagrangian points of the orbits, so that it would be possible to gradually send them further and further and eventually make interstellar travel possible. Now, the basic theory behind this initiative has been around since the 1980s, when Singer suggested that a stream of electromagnetically launched pellets could transfer momentum to a spaceship. This is a more general concept, which would be better. I mean, this could be applied, we won't even need the high quality optics for a laser. And when we talk about so the next point that I'm talking about is when we talk about interstellar travel, we can hardly avoid mentioning the warp drive, the classic sci-fi transport. Now, Alcubierre was the first to come up with the concept with his metric. But back then, it required negative energy density, so basically exotic matter. But after much more interest and research, it has been shown that the warp drive could be achieved with positive energy. In Bobrick and Matter's Introducing Physical Warp Drives paper, uh, they have used a different metric to show the warp drive being possible with positive energy, but with the limitation of it having a subluminal speed. Although this speed was still much greater than the ones we are currently capable.
UI.
Yes.
So you were talking about web drives being possible for our traveling, but you are forgetting about the fact that maybe the travelers may starve or dehydrate or suffocate. Even wars might happen inside the spaceship, maybe. So
So the hazards of space have always been there, even in the missions which we have within the solar system. Even the missions to the moon have had these hazards, but those can eventually be overcome with proper safety conditions. Um, and so another thing is that many other hybrid technologies are possible, which we have not had the time to mention. For example, we could have ramjets, which could use the interstellar hydrogen, and they could, by itself, it won't be sufficient. So they could use light sails and ion thrusters as well to provide enough thrust for an interstellar vehicle. So the whole point being that new innovations keep happening in our field, and we should be open-minded to the possibility that interstellar travel could be possible. Rutherford
POI.
in 1933, sorry, no, 1933 said that the energy produced by the breaking down of the atom is a very poor kind of thing. Anyone who expects a source of power from these transformations of the atom is talking moonshine. But in 1938, nuclear fission reaction was discovered, and we know
20.
now that nuclear power is a stable source of energy. So all in all, the point is that what seemed impossible some time ago, even in theory, is gradually being proven possible, and it's just a matter of time, motivation, and dedicated research required to make interstellar travel a reality. Thank you.
Thank you, second speaker from the proposition, for your arguments. I would now request the second speaker from the opposition to present their arguments.
Good evening, everyone. Yeah, I am Prasad Machado. So, yeah, so are you going to start timer as I say 1, 2, 3? Hello. Am I audible? Hello.
Yes, Prasan, you're audible. You may start your speech. The timer will start with your first word.
Okay. So, sure, let's start. as the proposition already said, uh, the thing is that it's possible and all those stuff. But what you all are doing is that the same thing which H.G. Wells did somewhere around 200 years ago. He wrote a book called Time Machine, and that book is still not available. Still, scientists cannot create a time machine, and it's not available. I understand there are physics things which are not available to that now too, but yeah, that's somewhat which you are doing in that part. Moving on to the researches particularly to this topic, which makes it inevitable, is that we all know that one of the fastest manned vehicle ever was Apollo 10 rocket, which reached the speed of nearly 25,000 miles per hour, which would get to Alpha Centauri, the nearest star, in 1,20,000 years. Hence, propellant tech doesn't hold good for this thing. Okay, but if you're really eager to use this tech, such rockets should reach within human lifetime. You need to get to 10% of the speed of light. All right. It can be accomplished with any liquid rocket fuel, but then you will need a fuel tank larger than the observable universe. Can you imagine that? Larger than the observable universe. All right. So this most probable technology is not available in this sense. But there are more two other ways to accomplish high velocity. So here I am in your favor, but let's see how it ripples down. Namely, propel a lot of mass backwards and propel less mass at much higher speeds. But then later one seems to be much available. See how I'm landing with you all, but the things will change for now. Just because of the famous Einstein's equation E equals to mc square. Such phenomena, that is fusion, happens quite inevitably in sun, but we cannot build a mini sun right there in a rocket which will boost right there up. So it again falls down to nothing. Going up to the second point, now let's
Right.
consider modern thermonuclear device. All right.
So fusion reaction is being considered in research right now, the tokamak and all of that. So how can you say that a mini sun? It's not technically, it's not exactly a mini sun, but it's still fusion itself is being considered. So how is that a valid thing?
Yeah, fusion itself is considered. I have visited many laboratories, VRC, and all those stuff. I know fusion itself is possible. But when we talk about rocket sciences, it becomes a bit difficult, and engineering wise, it's not that possible to take fusion as a concept and do an interstellar travel. All right. So let's talk about antimatter drives. When matter meets its antimatter counterpart, both particles and other thing annihilate, and which we get rest as energy. So there are many advantages and stuff, but disadvantage right here is that that's something like we need 50 times more energy per kilogram fuel than the best fusion options. So here's another disadvantage to this antimatter drives. Coming out to the new one of the newest approach towards interstellar uh, travel is this called something called as Schwarzschild Kugelblitz. It's a German name, I guess. Yeah, it's a German. Now, what happens? This Schwarzschild Kugelblitz. This is an engine powered by an artificial black hole. So there is no doubt it's the fastest option, but there is a drawback right there. They are using lasers in order to build black holes, and using that black holes, they're gonna boost a rocket right there. Now, how which is it possible to make or create a mini black hole in order to boost
UI.
the rocket? It's just, yeah, all right.
It
But you
makes
cannot
it
make a
give.
PI. I just have 30 seconds.
All right,
Yeah,
fair.
so I should continue. Yeah. So the thing is that it's not possible, and it's not possible in 50 years and all those. So I understand you're barring that we should not consider lifespan, But engineering wise, we have to understand it's not possible. Yeah, I'm done with that.
Thank you, second speaker opposition, for your arguments. I now request the third speaker from the proposition to present their arguments.
Okay, I'll tell you. Start then, please. Okay, so 3, 2, 1. Good evening, everyone. This is Megha Mugarkar here, and today I am the government whip. So let us begin here. We never talked about antimatter drive, and we never talked about Schwarzschild, well, whatever it was. So we are only claiming those interstellar travel possibilities which are actually possible, which have papers on them, which are proven. So I guess the opposition is just grasping onto straws here. Now coming to the point.
POI,
Yeah, go ahead.
can I say? I never mentioned that you all mentioned what I mentioned. I
Okay,
never said that. I said it's one of the approachable thing, but it's not acceptable till now.
yeah,
I
but
never
well,
said that.
we are
It's
not
been done.
at all taking antimatter drive and Schwarzschild, whatever you said, into consideration. We are not at all talking about that.
Yeah,
So
so it's
that point is
okay if
null
you're
and
not
void.
taking. I'm
And
also not
coming to the
saying
point,
that
the
it's.
opposition asked about.
I would
Prasun,
request
it's
the
not a
opposition.
Yeah, all right.
discussion. Your POI is done.
All,
May I proceed now?
Yes, Megha.
Yes, please.
Yeah.
Yes, yes.
Okay. So the opposition asked exactly how this interstellar travel can be achieved. Well, let me reiterate the fact that the second speaker made. The proof of warp drive being physically possible without the requirement of exotic matter was actually published in a paper just this year. So there was a point when this wasn't even a possibility. What I'm trying to say is that only through concentrated efforts and more research in this field that we'll be able to achieve this phenomenon. The reality is set. The travel is possible. Now it is up to us to make it happen. Now I must come to another point, and that is that the opposition is hinting towards disbelief that the interstellar travel itself is possible. Well, sorry to burst your bubble, but we are already doing space travel. It is happening. It is happening at a speed lesser than the speed of light, but it is happening. My point being here that we are not starting from scratch anywhere. And maybe after colonizing Mars, we will be looking out towards other stars. Now, I must ask the opposition
POI.
a question. Yeah, go ahead.
Okay, there's a difference between interstellar travel and the travel that's happening right now. Because right now, what we are doing is we are just aiming for stuff that are inside our solar system. Whereas interstellar travel requires us to aim beyond that. So how do you propose we do that? How is that a reality now?
All of the points that we have made before have been proofs enough that these are possible. And what point I was trying to make is totally different from what you perceived. So I'll go ahead. I'll ask the opposition a question. We have proofs, we have papers of the possibility of interstellar travel. What do you have that disproves this phenomena? I'll just give you a legit paper by Bobrick and Martyr, which they titled Introducing Physical Warp Drives. Is there any legit paper that counters their claims? Or for any recent paper that is claiming space travel? Is there any? You haven't given any. And you are talking about past technology. And we are telling you, we are giving you examples, we are citing papers that are very recent. They are of recent technology. And all that you have talking about have been past technology. It just doesn't make sense. And moreover, the technology that you have been talking about is very different from the one that we have been talking about. So how does that even make sense? Now I would like to talk about the very evident pessimism here. If it were 2 decades ago and you would have said all of these stuff, it would have made a little sense. It would even have been relevant that time. But right now, the research is in a very, very dynamic stage. People are taking this into consideration. There are articles that are being written here. So I think it is a little too late for your pessimism here. And taking point of the starshot breakthrough that the speaker one pointed out, and the speaker two expanded on, we are already underway. So I think the pessimism is a little too late here. Also, you all talked about the interstellar medium and the other debris, etc. Please tell me, when has that stopped us from sending out
20
satellites and
seconds left.
spaceships, etc.? Okay, now that is all that I have. And I would like to conclude by saying that it seems that the opposition is just trying to grasp onto straws. Thank you.
I thank the third speaker from the proposition for their arguments. I request the third speaker from the opposition to present their arguments now.
Am I audible? Hello.
Yes, you are.
Good evening. My name is Priyanka Sheet and I am from Blazars. Can I start now?
Yes, please.
Yes. So, the downside of this interstellar travel is that we don't know if Alpha Proxima B has an atmosphere, and given its closeness to Proxima Centauri's closeness, it would likely be exposed to dangerous solar flames and radiations. It is also very far away and would take 18,000 years to reach there. By that time, our descendants would have arrived there. Only if the spacecraft is light enough, it would uh, to be a paperweight, would this travel be possible. Now, coming to the points that were given by our opposition. So, the specific time frame is not debatable. Yes, but what about the descendants? What about our future descendants? What about them? Now, yeah, and I have a point on the warp drives. Um, Warp drives and ion propulsion are not much of use if our interstellar voyages starve, like I had said earlier, and it would be difficult to believe that a journey of at least 4.22 light years on an interstellar spacecraft would meet with no other object. But for a starship traveling at a relativistic speed, a collision would have the effect of an H-bomb explosion, according to Tom W. Ginzel of the Science Applications International Corporation. So it would be necessary to detect, deflect, or destroy the object within a matter of milliseconds before its impact. And you all were also saying about the ramjets. Now, um, the ramjets might need enormous electromagnetic field as a ram scoop to collect and compress the hydrogen from interstellar medium. This might need more energy and high speed into progressively constricted magnetic field. It would use 10 raised to 15 grams per second of solar material to produce velocity of 200 kilometers per second after 5 million years. This is not possible right now.
POI?
Yes.
We did mention that the ramjet wouldn't be by itself. It would be a hybrid system. So we would use ramjets and solar cells or something. So what do you say about that?
Yes, but it would take a long time from now. And maybe we wouldn't be even alive then. So that's what I have to say for now.
POI?
Yes.
The topic itself is not at all talking about time. So, what do you have to say about that?
It would take some time. I'm not saying that it would take right now or a few years ahead. I'm just saying that it's not possible right now. That's it. I just have this much to say.
Okay, thank you, third speaker from the opposition, for your arguments. We can now proceed to reply speeches. Is the reply speaker from opposition ready?
Yeah, all right.
All right, 3 minutes, no POIs, and anything beyond 3 minutes would not be heard at all. At sharp
Asha,
3 minutes, you'll have.
it's 3 minutes 20 seconds, right?
Mm, is it so?
That is just a buffer time.
Okay.
Like if we extend, so 20 seconds is like after that we'll have to force stop you.
Okay.
But yeah, 3 minutes is the limit. Like if you can wind up in 3 minutes, it's good.
Okay, so yeah, I'm the second speaker, starting with the reply speech. 1, 2, 3, start. So how it goes is that I appreciate your all the points, but the thing is that deceleration that greatly extends time required as you have to slow down by aiming your thrusting apparatus in opposite direction, presumably with an even more thrust and g forces than the acceleration if you don't want to start deceleration at the halfway point. So how will we have enough fuel or energy to start deceleration? We are not disagreeing or being pessimistic, as it was said, with the topic regarding interstellar travel. What we believe is that for something to be reality, it should be happening in our lifetime. But it's really that unreasonable to ask that a person who starts the mission also gets to finish it. I don't think so. Like if you're aiming to let dead bodies flow out there, it's just something. Forget about scientific. It's unhuman. All right. Because it's really because it's like I don't know. And the answer to the interstellar travel is not yes or no. It should also concern with humanity, human rights and stuff. And it's willing enough to pay for it and stop all our development because once the things are concerning to human beings, we should stop it unless it's within the human rights and concerns. You cannot just boast at the topic saying it's possible, it's possible, it's possible. At the end of the day, it should not cost a human life. That's important when you talk about scientific researches. I'm done with that.
Thank you, reply speaker from the opposition. Now, for the very last session of our debate, I'd like to invite the reply speaker from the proposition.
Hey, I'm the first speaker and I'll be the reply speaker for a side proposition. Yeah. Am I clearly audible?
Yes, you are. You may begin.
All right, fair. I'll give you a short countdown from about to begin. Okay, just give me a minute. Yeah. All right, sounds fair. I'll begin in 3, 2, 1. All right. So what we're going to do in the reply speech is tell you exactly what the opposition said, what we said, and how we clearly take it over them, and we don't actually see points where we both clashed because they didn't want to engage in things that we said. They actually all that they wanted to do was talk about every other method than the ones we mentioned. So yeah. So the first speaker from the opposition says that they question whether travel is realistic and feasible or not. They talk about Voyager 1 being the fastest things. They talk about having several generations of humans, or needing several generations of humans to actually reach the destination we desire to reach. They talk about dust particles and other things that would play a major role. And they also talk about antimatter and black holes and things we actually never mentioned. See, we clearly know what you are trying to do. You have obviously found out all the methods that we would fail in, but we are trying to tell you the things which are already underway, the research which is already underway, and things which are currently happening as we speak. The second speaker talks about the time travel book which still can't be proved, which is an anecdote he gives, while not actually telling me if he has done very good research. He should also tell me any physical phenomena which actually disproves the concept of interstellar travel. They talk about fusion not being possible in rockets, which is already happening and research is being done on that. And the only thing that we get from them is they're very pessimistic in their approach. And what I'm trying to tell you is this is the only pessimism that is stopping us from achieving where we want to go. If I wanted to prove my points by only mentioning the negatives and the failures of what has happened, then I would definitely be able to tell you that nothing in this world is possible. Hence, in this way, nothing should make sense. Bridges, nah, they break down. Rockets, nah, they blast midair. Moon missions, nah, they blasted on the base itself. Therefore, nothing actually happened because that is all that I told you. But let me tell you something. Everything that you said also had positive parts which you quietly ignored. You didn't even talk about it. We spoke about the Starshot initiative. We spoke about Singer giving the concept of electromagnetic pellets, which would provide momentum instead of photons, which you didn't even clash with us on. All right. Talk about the Starshot initiative. Talk about those things. Nah, that is none of our business, isn't it? The fact is that the only thing that is stopping us from achieving the interstellar travel is this pessimistic approach in itself. Like we mentioned, it isn't the research or time. It is just the fact that you only want to talk about the negatives while ignoring the positives. I give you very simple examples. Okay, Starship missions, the reusable rockets, they failed and they succeeded while everyone tried to give reasons to why it should fail. I'll tell you what. If I asked you for any research paper which disproves or outright prohibits interstellar travel from happening, you simply spoke about the methods which would fail and were beating around the bushes to find reasons why methods we didn't even mention would fail. But honestly, yeah. But honestly, if I had to prove my point, I would do the same thing as well. Because as it is clearly evident, finding out reasons to make it fail is clearly easier than engaging in the points that we actually mentioned. I'd like to end my speech here. Thank you so much. Therefore, we clearly take it forward. Side opposition.
Thank you, Reply Speaker, for summarizing this debate for us. We now, first of all, I would like to thank all six speakers for their speeches. The judges will now move on to this link and discuss amongst ourselves, and we'll come back to declare the winner. Judges, could you please join this link?
Yeah, okay.
All right. So yeah, so the feedback for CDM first speaker, Cryptic Dark Matter first speaker would be that it was a well-structured speech. I mean, you've done justice to all of your responsibilities as a first speaker very well. Like, you've defined the topic, you outlined what your team is going to do, and you tried to bring forth that main question that you wanted to debate on. And in the very first speech, that is in the CDM first speaker speech itself, it was made very clear that we are not looking at a time frame. We are not talking about, I mean, they had defined their topic saying we are not looking at what time we are talking about, maybe 10 years, maybe 1,000 years, but we're just saying that interstellar travel is possible. And they didn't keep a specific time goal for that. So that was made very clear in the definition. And maybe the first speaker from the Blazars should have challenged that, because that was a very most of the arguments from the opposition was about the fact that, okay, when is it going to happen? Like in 10 years, in 10,000 years, why it's going to take a long time. So maybe as a first speaker, you should have gone right ahead and said, I disagree to your definition, and let's and that actually it came in your reply speech. It came very late. Ki you're saying ki it will be reasonable to call something a reality only if it exists in our time era. That came in your reply speech. However, if that had come up in your very first speech as from the opposition side, it would have cost you so much. It would have been an advantage for you, and it would have cost you a little less, I think, fights, I would say, for lack of better word. Nonetheless, I really liked the. We really liked Blazars first speaker. We really think he, as a debater, the speaker gave really good, brought really good essence to the debate, and they kept asking POIs. Very, very engaging it was, and especially that possible, plausible, feasible, that thing that you said, it was really great. Okay, and yeah, so that was something really nice. So talking about CDM speaker 2, uh, you showed thorough knowledge of the subject. You showed ki, okay, we've done our research on how it is possible, and here it is. So that was really good from CDM part. And maybe one area you could improve on would be interacting more with the audience, in the sense like it seems as though you're reading off points. I mean, I know you are reading off points because you're presenting uh, physical facts, but yeah, maybe a little bit more eye contact would have been nice. But again, it's okay because it's online anyway. Yeah, so that's that. um, for Blazing Blazar's second speaker, starting off your speech with a sarcastic comment, though it was smart, a little humorous, but we felt it was a little disconnected to the entire debate that was going on. However, maybe it would have been better if you had maybe phrased it better, or maybe put it in some part between your speech maybe. But nonetheless, you did come up with solid arguments. You, as a second speaker, but you didn't. One thing you could have done better was clearly define your two arguments, what they were. We felt like you were holding on to the first speaker's argument and expanding upon it, rather than presenting new arguments upon why you think it's not a reality. Now, moving on to CDM speaker 3, we really liked uh, the energy you brought to the debate. But we were a little confused about how much sassiness is permissible in a debate. But since it's a debate, we are like, okay, fine, you take it, you have it, it's your floor, take it as much as you want. However, you really carried out your responsibilities as a third speaker very well. You really you stood your ground and opposed everything that came your way, and that was really good. And the major fact, I think, one really point of confusion between the two teams was that I think the opposition was talking about manned missions, whereas the proposition was talking about unmanned missions. And I don't know how you guys did not, that didn't click to either of the teams, because then, I mean, suddenly the people were talking about dead bodies in the space, and I'm just like, what? Why? So there was that clear, misunderstanding between unmanned and manned missions. And also, CDM speaker, Blazing Blazar speaker 3, as a third speaker, content wise, I know as a third speaker it's difficult to build content on the spot, because your speech is entirely made up during the course of the debate. But it is really, really important that you start from the first speaker onwards, from the very first word that the first speaker from the opposite team says. That's where your time begins, and you have to note down everything, even the slightest blunder that they make in terms of a language or a word that they use, that could be your hook to winning a debate, right? So so we do understand the fact that it is difficult to come up with content and all during the debate, because third speaker's debate is made on the spot. But we feel there we could have done, the third speaker from Blazing Blazers could have done a little bit better, but the speaker did try their very best to uh, knock down all the arguments put forth by a proposition. Coming to reply speech, we really felt the reply speech from the proposition gave us a better summary of what happened in the debate. And we also felt that the reply speech that came from the opposition tried to introduce new arguments in the reply speech. Like, I think the point of human rights, it was never talked about in the entire course of the opposition's debate, but suddenly in the reply speech it was there. And and as a reply speech, that's something we specifically mentioned in the rule book as well, that no new arguments. Anyway, but the reply speech from this proposition was really well put. That's how I think it's
Excuse
a.
me.
Yeah, sure.
Yeah, like I had a question. So, can't I critic
One
an
second, can I
argument in reply?
finish? 1 second. Is
Okay,
it
yeah,
okay
I
if I
just
finish my
yeah, all
feedback,
right.
declare the result, and
Yeah,
then you
all
ask me? Thank you.
all
All right. So, I think the reply speech given by the proposition is like a model reply speech for any debate. Like, it was really well structured, and it clearly gave us reasons to believe why Cryptic Dark Matter has an upper hand in this debate. So, evidently, congratulations, Cryptic Dark Matter, you are the winner. Yay! Clap, clap, clap. Yes, trust in your question.
so,
Are they?
uh, can I speak?
Sure, please.
Yeah, so I was saying, like, is it not allowed to critic an argument in reply speech?
No, that should have been done by a third speaker. Critiquing your arguments, opposing your arguments should have been done by your third speaker. And as a reply speech, all you should have done is summarize. Ki, I said that, they said that, we said this, you said that. And this is why,
Oh, right.
because we said this, is why we deserve to win this debate. You know what I mean?
Okay.
Yeah. So that's what I said. Like, the
Yeah.
reply speech that came from proposition is a very good sample as to how a reply speech is supposed to be in any debate. So if at least, like, if until now you didn't have an idea of how it should be, this is how it should be.
Okay.
Yeah, I now hand the control back to Saurav.
Okay, guys, we will have another debate at 8 o'clock.